Welcome to ClickMyProject.com. Let me discuss about the process massive MIMO with optimal power and draining duration allocation. Let me discuss about the abstract of the process. Energy harvesting is a highly promising technology which can support continuous power supply to energy constrained communication systems such as machine to machine and sensor networks. Usually the main goal of the EH communication system is to maximize the system throughput under some causality constraints. Harvested energy can originate from the far field radio frequency radiation of another device or from the ambient RF radiation. Some interference mitigation is offered by limited intercell coordination, which is conventionally restricted to scheduling or user assignment mechanism, or soft handover techniques. Intercell interference is treated as noise at the received side and is handled by resorting to improved point-to-point communication between the base station and the mobile station using efficient coding or single-link multiple antenna techniques. Optimal pre-coding over the broadcast MIMO channel as well as optimal joint decoding over the uplink involve non-linear computationally intensive operation which scale poorly with the size of the network. Finally, for an interference channel with more than 2 transmitters, it is also possible to specifically design transmit signals so that the interferences are always constrained at confined subspaces at each receiver. This allows the receiver to efficiently reject the interference. This idea, known as interference alignment, has been shown to achieve significantly improved multiplexing gain for the MIMO interference network, where both the transmitters and the receivers are equipped with multiple antennas. Let me discuss about the flow diagram for our process. Initially, the system model. System has L cells. Each cell includes one N antennas and BS and K single antenna terminals, where NK. All L cells share the same frequency band. Transmission comprises two phases: uplink training and data transmission. In uplink training, the BS estimates the channel from the received pilot signal transmitted from all terminals. In each cell, K terminals are assigned K orthogonal pilot sequences of length tau symbols, where T is the length of the coherence interval. Since the coherence interval is limited, we assume that the same orthogonal pilot sequences are reused in all L cells. This causes the so-called pilot communication. At the 1th BS, the minimum mean square error channel estimate for the kth column of the channel matrix G11, where PP is the transmit power of each pilot symbol. Next, in the data transmission, all K terminals send the data to the BS and be a vector of symbols transmitted from the K terminals in the nth cells. N cross 1 received vector at the BS is given by. Then BS uses MRC together with the channel estimate to detect the signals transmitted from the K terminals in its own cell. More precisely, to detect the signal transmitted from the kth terminal, the received vector is pre-multiplied and some spectral efficiency and achievable ergodic rate of the transmission from the kth terminal in the cell to its BS. The bit energy of the system defined as the transmit power expended divided by the sum spectral efficiency. And finally, the optimal resource allocation. Let P be the total transmit energy constraint for each terminal in a coherence interval. The transmitted powers of pilots and data to maximize the sum spectral efficiency. Finally, the performance has been analyzed. Let me discuss about the running procedure for our process. Select the main.m file in the current folder, right click the file and run for executing this process. After execution, this is the new deployment of our BS and MS placement, and this is the sum spectral efficiency graph without resource allocation and with optimal resource allocation. This graph plotted between versus bit energy and also some spectral efficiency. And this is the pilot power graph or data power versus by varying the SNR value. Here also we perform the graph between our without resource allocation and with resource allocation scheme. And this is the cumulative distribution function, that is CDF, by varying the sum spectral efficiency. And this is the capacity graph. By iterating the number, capacity will be increased when iteration will be increased. Here finally we achieve the capacity of full channel state information in the consider the all pilot powers is this value. Thank you.